Good evening, everybody. Good afternoon. Good morning. Whenever you're watching this video, this is Mr. Molikash. This is a beginning of series of videos that I'll be putting in Blackboard for Math 171 for Johnston Community College. If you're watching this video, you can send me an email at this email address, and if you're new to my class, you should have already noted that. If you want to get in contact with me through Blackboard, you can use the Ask Mr. Molikash discussion board. Again, this is just for my students for this current semester. And in week one of the course, you should have gone through the course walkthrough. So I put a video in there walking you through Blackboard and showing you the ins and outs of ALEKS. Assessment and Learning in Knowledge Spaces is what this stands for, and this is the companion tool to our online instruction. So along with me teaching you in these videos, you're going to be using ALEKS to kind of sort of get your hands dirty doing the math, and ALEKS will assess kind of where you are and tailor instruction to your learning needs, which is really cool. I think that's really cool that you can have something like that. All right, so in week two, get something to erase with. I didn't grab a towel. And in week two of the course, we've been dealing with section R in the textbook. Okay, so the R is the review section. So this is kind of reviewing stuff that you should have learned or at least have been taught in previous math classes. In a few minutes, we're going to talk through a couple of problems from section R.5 and R.6 and R.7. So there's a lot to really get your hands dirty with in ALEKS in week three. But in week two, you know, a lot of this stuff is kind of just getting yourself acclimated with ALEKS and doing some basic stuff like, you know, factoring the difference of squares, doing square roots, solving proportions, you know, those kinds of things. So, you know, if you haven't had a math class in a while, maybe this seemed a little bit of a struggle to you or maybe a little overwhelming, but just kind of keep in mind this is review stuff right now, and the rest of the class will kind of go back through these things in greater detail. Okay, so if you're feeling overwhelmed, again, send me an email, ask me some questions in the discussion board. I'm here to help, so you're not alone. All right, so upcoming now in week three, we're going to go through a couple of problems in section R5 of the Julie Miller pre-calculus text. And okay, so a couple of things is, you know, multiplying with square roots, okay, or using the quadratic formula or that kind of stuff. So how, for example, how do you multiply say square root 5 times square root 15 and simplify the answer? You know, this is sort of a basic thing that you should have, you know, some experience with, right? So, you know, if you think about this, you can factor these numbers under the square roots into their prime factors. 5 is a prime number. That can't be factored. 15, you can factor in the 3 times 5. And it's possible to put all of these factors under a single square root. Okay, now 2 of these repeat, and so if you multiply 5 times 5, you get 25, but the square root of 25 is 5. So what happens is, if you have a pair of these under a single square root, you can mark out the pair and put one of those factors on the outside. Exactly half of the pair goes on the outside when you do that. If there's not a pair, it stays on the inside. So the answer to this is 5 square root 3. Okay, I would do this, and I would not do this. I would not multiply and do the square root of 75 because that makes the number big. Okay, and then what you have to do with 75 is break it back apart again, right? You have to factor it. So since these numbers are already smaller, just keep on making them smaller. It's easier to work with smaller numbers than bigger ones. Okay? All right. So moving on, now we're going to do a factoring problem. And again, this video is not very specific, okay? I'm just kind of like jumping around to different things that you might have to encounter. All right, for example, there's an example in a textbook that says, solve this equation. Solve 2x times 2x minus 7 equals negative 12. Okay, well, because there's more than one x over here, the only way to solve this is by multiplying this stuff out and letting one side equal 0. And the reason for that is because we're going to use a principle called the zero product property. So what that means is that if you multiply two numbers together and you know the answer is 0, then at least one of these has to be 0. Because 0 times anything is 0, and anything times 0 is 0. And they both could possibly be 0 too. So, but since we don't know which one it is, we look at both possibilities. Either this one is 0, or this one is 0, or both. But without having that 0 there, we can't use that. Okay? It's much more difficult if we had negative 12 here, like in the example above. There's lots of different things that multiply to be negative 12, and so the possibilities are almost endless because there could be fractions involved. One could be negative and one could be positive. We know that, but and we know neither one of them is 0. But there's so many possibilities that it's kind of difficult to use the property that we were looking at before. Okay, so what we're going to do is we're going to multiply this stuff out. We're going to use the distributive property, and we get 4x squared minus 14x equals negative 12. Now, in order to let this be 0, we have to add 12 to both sides. So adding 12 to the left side means we have a plus 12 on it. Adding 12 to the right side means we get 0. Woohoo! We have 0. Okay, so the next thing we're going to try to do is factor. And if you're, if you're not familiar with factoring, what we want to do is we want to break this apart into little factors like it was up here. However, we have something different than we had before. So the first thing you always do when you factor is you look at all the coefficients and you see if you have a common factor, and you do. All of these can be divided by 2. So we're going to factor the 2 out. And sorry, there's a 2 there. 2 times 2 is 4. 2 times 7 is x, and then there's a 6. Okay. And then what's left over is a trinomial that is quadratic. And I know I'm probably using some fancy words, but trinomial means 3 terms. Quadratic means the degree is 2, x squared. And we'll talk more about this in depth as the course progresses. So don't, again, don't get overwhelmed. But what I want to do here is I want to fill in these first 2 spots with factors that multiply to make 2x squared. And that's not too bad. One of these is going to be 2x and the other one's going to be 1x. And 2x times x is definitely 2x squared. And you might say, hey, Mr. Molikash, I could put 2 there and x squared there, and that is definitely true. But the reason why you want both of these to have an x in them is because of this middle term. Okay, we're going to find out what's going on there in a minute. So what we want to do in the end here is we want these 2 things multiplied together. Okay, so something x, and then these 2 things multiplied together, so 2x times something, to total up to be negative 7x. Okay, that's kind of what we want to have happen. So 2x times what plus what times x equals negative 7x. And then there's one more restriction. The things that go in this blank, these 2 blanks that go here, have to multiply to make positive 6. So it's kind of like anything else in life. The more you do these, the better you get at it. So the numbers that work out are 3 times 2. Okay, and they're both negative. Okay, so watch what happens if I put a negative 3 in front of this x, and I put a negative 2 multiplied by that 2x. So I get negative 3x and negative 4x, which sure enough makes negative 7x. Okay, all right, so there is our our factors. Okay, and I'm going to need some room, so let me put all this stuff at the bottom up here at the top. Okay, so remember what we're having to do is solve this equation, right? So now we have three different possibilities. Either 2 is 0, or 2x minus 3 could be 0, or x minus 2 could be 0. This is not ever going to work out. If you can figure out a way to make 2 equal 0, please let me know. Email me right away so that we can get rich together, because if 2 equals 0, we can get millions and millions of dollars very quickly for free. Not going to work out, right? But these do work out. So these are pretty easy. Hopefully you already know how to solve these. If not, you might want to replay this in slow motion. But that's 3/2 is one solution, and then here we'll add 2 to both sides and get 2. And so these are both answers. Those are both solutions to the original question. Okay? All right, so we're going to move on to R6 now. Excuse me. At the moment I'm shooting this video, it's in January and the weather is kind of crazy. It's going back and forth between cold and being warm. Today it was like 60 degrees outside. By the end of the week it's going to be 18. So, you know, that's kind of North Carolina weather for you. All right, so another thing we're going to have to do is we're going to have to take square roots of negative numbers. So the reason why a square root exists, if you want, like, say, the square root of a number is 5. Well, the reason why that is the case, that the square root of some number is 5, that's like saying that 5 times 5 is equal to the number. So the square root is the thing that when you multiply by itself, you get the number under the square root. So 5 times 5 is 25, so that means that this should be 25, okay? Obviously, the square root of 25 is 5, okay? So what we want to do is we want to say, okay, what's the square root of a negative number, like -1? Okay, well then that means that some number times itself has to equal -1. And with the number system, the way that we know it, that's not possible. You can think of some numbers like you can have 1 as 1 and 1 as -1, but remember it has to be the same exact number. We can't change the question mark to, you know, an exclamation point or something like that. Both of these have to be exactly the same thing. So if they're both 1, you get 1. If they're both -1, you get 1. But we want the answer to be -1, right? So this conundrum really baffled mathematicians for centuries, and so much so that they had to imagine what the answer to this might be. And so they called this the imaginary number, and they call it I. And so I is defined as the number that when multiplied by itself, you get -1, okay? So that's called the imaginary number. And why do we have this? So that we can take square roots of negative numbers. Why do you need to take square roots of negative numbers? Well, it's because of this thing that we call the quadratic formula. So the quadratic formula kind of goes like this. If you have a quadratic equation and you can't factor it, but you want to find the solutions, then what you do is you use this formula. If we have this equation, then x equals -b plus or minus square root b squared minus 4ac all over 2a. Wow, what a complicated looking formula, right? Okay, well, the problem with this formula is, one, it's kind of complicated. There's going to be a lot of work involved, and there's lots of spaces where you can mess up. But another big problem is, what if this thing under the square root is negative? Then that's where the imaginary numbers start coming into play. We need imaginary numbers because of this formula, so that we can find the solutions to these quadratic equations, okay? So here's what I mean, okay? Let's go through an example. And again, I'm just kind of thumbing through the e-text here, getting some, you know, what we call examples that are in the book. Okay, so okay, here is an example. Okay, let's solve this equation. Let's say that we have um, 5/12 x squared minus 1/2 x plus 1/4 equals 0. And if you're reading through your textbook, like I encourage you to do, you'll know where this is. So, okay, first off, we don't like fractions. Nobody likes fractions. I admit I don't really like them either. So what we're going to do is we're going to multiply both sides by the common denominator. This is the smallest number that 12, 2, and 4 divide into evenly, and that's 12. So I'm going to multiply both sides by 12, and that kills off all the fractions. So here the 12's cancel out, and you're left with 5x squared. Here I'm going to multiply 12 times 1 and then divide by 2. So that's 6x. And then 12 times 1 and then divided by 4 is 3. And so this is much easier. Okay. Now, what you could do is to try to factor this, right? You say, okay, what else? What times what else is 0? And, you know, this doesn't work out, unfortunately. There's no way to make the factors work out. Like if I put a 3 here and a 1 here, you'll have 3x and 5x, which can't make 6x, much less negative 6x. Even if one's negative and one's positive, if you subtract 5 and 3, you're going to get either 8 or 2 if you add or subtract. And you might say, okay, well, what if I put the 1 there and the 3 there? Still doesn't work out. Here you have 15x and here you have 1x. So this just doesn't factor, and therefore we need to use the quadratic formula. Okay, so A is 5, B is negative 6, and C is 3. All right, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so negative b is the opposite of b. B is already negative, so when I do another negative, that's going to be positive. Okay, plus or minus square root. Negative 6 times itself is positive 36. Negative times a negative is a positive, right? And then 4 times 5 times 3. And I think I'm doing this right. Yeah. Okay, so just wanting to, sorry about that. I was just making sure that I copied everything down correctly. All right, so an A is 5. All right, so what a mess this is right here, okay? But just kind of hang in there. I'll help you get through it. And again, you know, because this is a video, you can always go back and hit pause or rewind and play what I'm saying over and over again until it makes sense to you. And don't forget, you can email me and ask me questions in Blackboard. All right, so let's keep on going. So the next step is to try to put all this stuff together under the square root. So 6 plus or minus square root 36 minus, let's see, 4 times 5 is 20, 20 times 3 is 60, and what do you know? Let's see, 2 times 5 is 10. Okay, so now what happens is, this thing under the square root turns out to be negative. All right, that's going to be negative 24. Okay, so right off, I can tell you that whenever a negative is under a square root, what you're going to have to do is take and put an I on the outside of it. Okay, because the square root of negative 1 is I, and then this, now what we have to do is figure out what the square root of 24 is. Well, 24 factors into 4 times 6, and 4 is 2 times 2, and 6 is 2 times 3. So if you take the time to do like I did earlier in the video, you'll get all this stuff. Okay, all right, so now moving up here. Okay, x is 6 plus or minus I times 2 square root 6. There's no more pairs left here, so that becomes a 2 on the outside, like I said earlier with the 5. All All right, now 6 and 10 can reduce to 3 and 5. 6/10 is the same thing as 3/5. And then 2/10 is the same thing as 1/5. So I'm going to put I, and then that what used to be a 2 is now a 1. Okay, so there you go. Our answers are 3/5 plus or minus I times the square root of 6/5. And in the book, it says to do this, 3/5 plus or minus square root 6/5 times I. So they put the I after it. It doesn't matter where you put it. But in ALEKS, if you're having to type this out, you might have to put this in front of the I instead of behind it. All right. So that's just a little flavor of what's going on in R5 and R6. There's definitely a whole lot more. Be patient, be committed, hang in there through these first couple sections in review. It does seem heavy and overwhelming at times. There's a lot going on in there, but hang in there. I'm here to help you. Don't forget about the discussion board. Send me an email, and don't fall behind. Stay committed with this and work on it every day if you can. Thanks so much. Have a great week.